we're going to do with limits is we always plug in, because nobody out there in the real world is going to be like, use L'Hopital's rule to evaluate this limit. They're just going to say, here's the limit, we got to figure it out. So the first thing we do is we plug in, and in this case when I plug in, I get 3 squared minus 9 over 3 minus 3. So I do in fact have 0 over 0. Now, when you have that 0 over 0 case, you actually have two options. So the first option is that you can factor out, and we talked about this at the beginning of the semester. If x is going to 3, you would be factoring out x minus 3. You then cancel out the x minus 3 and then plug in. Now, this works, this factoring, canceling, and plugging in. This works if you have a fraction over a fraction, or I shouldn't say fraction, a polynomial over a polynomial that you can actually factor. So in this case, we have that polynomial over polynomial structure, so we could factor, cancel, and plug in. Now, the other method is L'Hopital's rule, and L'Hopital's rule is a more generic case of how we can deal with the 0 over 0 situation. So with L'Hopital's rule, we take the derivative of the top divided the derivative of the bottom, and we hope that we can then find the limit of that new fraction of its derivatives. So just as a quick reminder, if I wanted to go through this factor, cancel, plug in, what I would do is I would factor this as x plus 3, x minus 3 over x minus 3. Then I would cancel out the x minus 3's. That would leave us with the limit as x goes to 3 of x plus 3. And then I would plug in the 3, because that's what I'm going towards, and get 6. Now, if you compare that to using L'Hopital's rule, what you would do with L'Hopital's rule is you would start with the original limit, and then you would take the derivative of just the bottom, which would give you, or just the top, excuse me, which would give you 2x, and then you would take the derivative of the bottom, which would give you 1. And then you would look at the limit as x goes to 3. Now, at that point, after you differentiate, you just kind of ask yourself, well, if I forget about everything else in the world and I just look at this limit, how would I evaluate this limit? Well, I would plug in. So if I plug in 3, do I get a finite number? And I do. So plugging in 3, 2 times 3, I'm going to get 6, and that is my finite number, so that is my limit. So you'll notice here, using either L'Hopital's rule or the method that we learned in test 1 with our limit material, both give us 6.